Hello, welcome to everyone. In this video, this is lecture number 10 on digital electronics. Today we want to discuss about the multiplexer, demultiplexer, decoder and encoder. You can see this syllabus, this portion, that is integrated circuit, number system, digital circuit and implementation of the different circuit already discussed. Today we want to cover up this portion number 5, that is the multiplexer, demultiplexer, encoder and decoder. And upcoming session we will be cover sequential circuit, register counter, computer organization, data conversion. So let's start. Multiplexer actually is that there is many inputs in which one of these input goes to the output. So which input goes to the output is selected by selector. So depending upon the number of inputs, selector's number is defined, and after that the output which inputs are outed is controlled by this selector. Okay, there is a enable input which actually control this total multiplexer. When enable is 1, this is active, and when this is 0, this is inactive. This selector two selector, these are the 4 types, 4 inputs. So maximum inputs will be 4. Okay, so you can see depending on the selector, I0 is inputted for 0 0. That's why you need to take the S0, S1 bar and S0 bar. Okay, for I1 this is S1 bar and S0. That's why you take this one, and finally output will be this. For this is for 4 input. In case of 8 input, 8 to 1 multiplexer, you can you need to take the 3 selector such that you will be obtain the 8 types. So 3 selectors arrange in like that: 4041, 2021, 2021, 1011, etc. And for that this is I0, I1, I2, etc. So just taking this S2, S2 bar, S1, S1 bar, S0, S0 bar. So I0 when taken, this is 0 0 0, so bar, and this is for 1, I2, and similarly for I7, and taking this into OR gate. Clear? Next is cascading of 2 4 to 1 multiplexer. If you want to find out 8 to 1 multiplexer using 2 4 to 1 multiplexer, you can take this enable this C actually 0 and 1. So when this is 0, this is 1, when this is 1, this is 0. So this is 0, this is 1, when this is 0, there is a 4, and this is 1, there is a 4. So 4 to 1, 4 to 1. For that one you will be get D1 to D3, and for that one D4 to D7, and they are added up, so finally obtain the same things. Okay. So using 2 4 to 1 multiplexer, you can easily find out 8 to 1 multiplexer. Next thing is realizing the function using 8 to 1 multiplexer. So this is the function, at the 0 3 5 7 are 1, no, 0 3 5 7 and others are 0. So you will be take this I0, I1 in that value, that is I0 is 1, I1 is 0, and etc. So you will take this value in this multiplexer, you will be obtain this output, right? Next thing is de-multiplexer. This is something the reverse of multiplexer. In multiplexer, you have many inputs and single output. So in reverse, there is one input and many output. So this input will be outputted in which outputted from which output is depending upon the selector. So selector select which input is come out from which in output. Okay. So the circuit diagram will be like that. Next thing is decoder. Decoder is similar like to demultiplexer, but there is difference. In demultiplexer only one input and the two selector, but here is selector actually no selector. The selector actually act as the input. Okay, so this decoder actually decode the binary to decimal. If you change binary to decimal, the circuit will be like that. For example, 4 to 10 decoder, that is 4 bit and you 10 output is like that. Actually, I want to share that 4 to for small 2 to 4 decoder. 2 to 4 decoder is nothing but A and B, that is, or BA, that is 00011011. For decoder, this is 0, this is 1, this is 2. Actually Y0, Y1, Y2, Y3, etc. So Y0 is nothing but B bar, A bar, and B bar, A bar. So this is A, B bar, this is A bar B, and this is A B. So this actually 4 2 to 4 decoder, and 4 to 10 decoder is like that. And there is a enable which is actually helps whether the decoder working or not. Next important thing is encoder. Encoder actually encode into the binary number. For example, if you encode it from decimal, decimal means 10 digit, so 0 to 9. So 10 digit are encoded by BCD, binary coded decimal. So it can change I1, I0 is 1, so all is 0. I1 is 1, so this is A is 1. I2 is 1, there is 1 0. Just equivalent, this is equivalent to 2. This 3, 4, 5, 6, 7, 8, and 9. So these are changes into decimal to binary, decimal are encoded, binary encoded. So you can see this D is 1 when 8 I8 and I9 is 1. So D is I8 plus I9. So take I8 and I9 plus. Then C is 1 where this is I4, I5, I6, I7, I4, I5, I6, I7. And B is 1, that is the I2, I3, and I6, I7, I2, I3, I6, 7. And A is I1, I3, I5, I7, I9. So using this OR gate, you will be get easily find out the encoder. So I think clear about multiplexer. That's mean many input, one output. Demultiplexer, one input, many output. Decoder is nothing, that is the binary coded number change into decimal. Encoder means decimal number change into binary. So these are all 4 things you need to know about it. This is all about me. This is my contact detail, and this is my YouTube channel. So take care. We'll meet on the next video as soon as possible. Thank you.